Bismillahirrahmanirrahim. Start with the name of Allah, the most gracious and the most merciful. My name is Isha Shafiq and I am from the Department of PS Chemistry. The topic of my presentation is Korean testing for industrial metals and protective coatings. So let's start it. First, our point is aim. The aim is to systematically evaluate the Korean resistance of selected industrial metals and their associated protective coatings under controlled environmental conditions using standardized Korean testing methodologies in order to quantify material degradation rates, assess coating performance, and determine susceptibility to specific Korean mechanisms for engineering applications and material selections. Theory. Introduction to Korean. Korean is the gradual deterioration of a material, usually a metal, as a result of chemical or electrochemical reactions with its surrounding environment. In industrial applications, Korean leads to material degradation, loss of mechanical strength, reduced service life, safety hazards, and significantly economic losses. The presence of moisture, oxygen, salts, acids, or industrial pollutants accelerate Korean processes, making Korean testing essential for material selection and protective designs. Electrochemical nature of Korean. Korean occurs when a metal is exposed to an electrolyte, such as water containing dissolved salts. The metal surface develops anodic and cathodic regions. Anodic reactions, which is given below, and cathodic reaction in neutral or alkaline medium. The flow of electrons from anodic to cathodic sides results in material loss at the anode and which manifests as Korean. Korean testing of industrial metals. Korean testing is conducted to stimulate real service environments and evaluate the durability of metals. Common Korean testing methods include immersion testing, salt spray testing, and electrochemical testing. Protective coatings and their role. Protective coatings are applied to metals to reduce Korean by acting as a physical or chemical barrier between the metal surface and the environment. Function of protective coatings: prevent contact with moisture, oxygen, and aggressive ions, reduce electrochemical reaction, improve surface durability and appearance. Types of protective coatings: organic coating, paint, epoxy, and polyurethane; metallic coatings, galvanizing and electroplating; conversion coatings, anodizing, phosphating; polymer and composite coatings. Apparatus and material. The apparatus includes a salt spray chamber, electrochemical workstation, 3-electrode electrochemical cell, analytical balance, glassware, pH meter, drying oven, thermometer, and surface preparation tools. The material consists of industrial metal specimens, protective coatings, corrosive solutions, and cleaning chemicals. Chemicals include sodium chloride, hydrochloric acid, sodium hydroxide, ethanol, or acetone. Environmental procedure. Preparation of test specimens. First, we will prepare the specimens in which we perform our test. Cut the industrial metal specimens to standard dimensions as per laboratory requirements. Polish the specimen surfaces using emery papers of progressive finer grit sizes to obtain a smooth uniform surface. Clean the specimen thoroughly with distilled water followed by degreasing using acetone or ethanol to remove oil, grease, and contaminants. Dry the specimen using a hot air dryer and allow them to air dry completely. Measure and record the initial weight of each specimen using an analytical balance, accuracy plus minus 0.1 mg. For coated samples, ensure uniform coating thickness and allow curing before testing. Immersion Korean testing, which is also weight loss method. Prepare the corrosive solution, for example 3.5 to 5% NaCl acidic or alkaline solution using distilled water. Pour the prepared solution into a clean glass beaker. Suspend the metal specimen in the solution using a nylon thread, ensuring that it does not touch the wall or bottom of the beaker. Maintain the test temperature at room temperature or as specified in the experiment. Allow the specimen to remain immersed for a predetermined exposure time, for example 24, 48, or 72 hours. After exposure, remove the specimen and rinse it with distilled water. Remove Korean products using appropriate cleaning solution as per standard procedures. Dry the specimen and record the final weight. Calculate the weight loss and Korean rate using standard Korean rate equations. Salt spray Korean test. Prepare a 5% sodium chloride NaCl solution and fill the reservoir of the salt spray chamber. Place the cleaned and prepared metal or coated specimen or specimen holder inside the chamber at an inclined angle, typically 15 to 30 degrees. Set the chamber temperature approximately commonly 35 plus or minus 2 degrees Celsius and start the salt spray system. Expose the specimen to continuous salt mist for the specified duration, for example 24 to 96 hours. Periodically inspect the specimen for rust formation, blistering, cracking or coating delamination. At the end of the test, remove the specimen, gently rinse with distilled water and dry. Record visual observations and compare corrosion behavior of coated and uncoated samples. Electrochemical Korean testing. Assemble the 3-electrode electrochemical cell containing the electrolyte solution. Connect the metal specimen as the working electrode, Ag or AgCl or SCe, as the reference electrode and platinum as the counter electrode. Connect all electrodes to the potentiostat. Allow the system to stabilize and record the open circuit potential OCP. Perform TEFL polarization measurements to obtain corrosion potential and corrosion current density. Conduct electrochemical impedance spectroscopy EIS to evaluate coating resistance and capacitive behavior. Save and analyze the electrochemical data using the workstation software. Next, our point is techniques that are used in Korean testing. First one is weight loss gravimetric Korean technique. Its principle is this technique is based on measuring the loss in mass of a metal specimen after exposure to a corrosive environment for a specified period. The reduction in weight corresponds to the amount of metal corroded. Its formula or calculation is Korean rate is equals to kxw over A multiplied by T multiplied by D. Advantages: it's simple and reliable, provides average Korean rate suitable for industrial metals, and the limitations are not suitable for localized Korean, time consuming. Salt spray Korean testing. Its principle is salt spray testing accelerate corrosion by exposing metals or coated specimen to a fine mist of sodium chloride solution in a controlled chamber simulating marine and industrial environment. Test conditions: NaCl concentration approximately 5% and temperature 35 plus or minus 2 degrees Celsius, which we discussed earlier. Continuous fog generation. Advantages: rapid results, standardized methods, widely used in industries or accepted in industries. Limitations are does not replicate all real world conditions and qualitative in nature. TEFL polarization technique. Principle: TEFL polarization involves applying a controlled potential to the metal and measuring the result current to determine corrosion kinetics. Measured parameters: corrosion potential E core, corrosion current density I core, which we write as I core. Significance: higher the I core means higher the corrosion current density, higher corrosion rate. More positive corrosion potential E core, which is greater corrosion resistance. Advantages: fast and accurate, sensitive to small changes, and its limitations are require electrochemical setup and surface condition sensitive. Next, our point is electrochemical impedance spectroscopy, which we discussed. Principle is EIS measured the impedance of a metal or coated surface over a range of frequencies to evaluate corrosion resistance and coating integrity. Parameters are change transfer resistance RCT, coating resistance RC, and double layer capacitance CDL, C_DL. Interpretation: Higher impedance, good corrosion resistance, decrease in impedance, coating degradation. Advantages are it is non-destructive, highly sensitive and suitable for coated systems. Limitations are complex data analysis and require expertise. Calculations and formulas. First, our technique was weight loss method, and its formula is weight loss is equals to weight for initial mass and weight for final mass, where Wi is equals to initial weight of specimen and Wf is equals to final weight of specimen after corrosion. Formula which we also mentioned earlier, where W is the weight loss, A is the surface area of specimen, T is the exposure time, and D is the density gram per centimeter cube. K is the constant depend on unit. Common values of K are 8.76 into 10 raised to power 4 Korean rate in mm per year and 534 Korean rate in miles per year mpy. Surface area calculations. Rectangular specimen. Area is equals to 2LW plus LH plus WH, where L is equals to length, W is equals to width, which is in centimeter, and height, thickness, which is also in centimeter. Salt spray test evaluation. Korean rate if weight loss measured. Same formula as gravimetric method. Coating performance evaluation. Higher time indicate better Korean resistance. Tefel polarization technique. Korean current density obtained from Tefel extrapolation curves. I-core micro A over centimeter square. Korean rate from Tefel is, these are the values we get from the experiment, where I-core is equals to Korean current density, which we also discussed earlier, micro ampere per centimeter square. EW is equals to equivalent weight of metals, and D is equals to density gram per centimeter cube. Equivalent weight is equals to atomic weight over valency. Fourth one is electrochemical impedance spectroscopy, EIS. Charge transfer resistance. RCT is equals to Z lower frequency is minus Z higher frequency. Higher RCT means lower Korean rate. Coating efficiency. Coating efficiency in percentage is equals to R coated minus R bare over R coated multiplied by 100. This is its formula. Protection efficiency of coating, we have its formula, and where CR is equals to Korean rate. Percentage weight loss is equals to Wi minus Wf, which is weight of the specimen, initial weight of the specimen, and Wf is the initial final weight of the specimen after corrosion, over Wi multiplied by 100. Some sample calculations which we get: initial weight, final weight, area, time, density. Then we get the weight loss, Korean rate. After applying all the values in the formula Korean rate, we get the values. The result of the Korean testing generally provide information on weight loss or Korean rate. Salt spray observations, electrochemical test parameters, Tefel and EIS, coating performance and or protection efficiency, percentage weight loss table. And these are all the tables. First one is weight loss or gravimetric test table. Observation is stainless steel show lowest Korean rate due to the highest resistance, and aluminium show moderate Korean, mild steel corrodes significantly, and copper shows minimal weight loss. Salt spray test analysis. Here is its table, where we have mild steel and stainless steel, aluminium and copper. Rating scale is 1 is equals to excellent, no Korean means, and fifth one is the where we use 5, which is poor or severe, severe Korean. Here we can see that its 4 means it is closer to poor one. Electrochemical test results. Observations show that coated specimen exhibit significantly lower I-core, indicating higher Korean resistance. Next one is electrochemical, result of the electrochemical impedance spectroscopy, where we also draw the table all the values, and the result or the observations show that higher RCT and coating resistance indicate better protective efficiency. Coated sample show 85 to 92% protection compared to uncoated metals. Last one is percentage weight loss table, where we get all the percentage of the values. Weight loss values confirm that trend observed in Korean rate calculations. Mild steel crude the fastest, copper the lowest. Summary of the results: mild steel, rapid Korean without coating, significant protection with epoxy coating. Stainless steel, excellent Korean resistance even without coating. Aluminium, moderate Korean anodizing improves protection significantly. Copper, very low Korean rate, generally resistant in neutral saline environment. And the last point is coating, which is epoxy anodizing and polymeric coating enhance Korean resistance and delay first rust appearance. Thank you so much for your attention. Allah Hafiz.